In this video I'm going to build this tester for 4116 and 4164 DRAM ICs. If you're restoring or repairing a ZX Spectrum or Commodore 64, this will be a useful tool for testing the memory chips away from the main circuit. The kit itself comes with a double-sided PCB, all the components required to make this kit work, an Arduino Nano which is pre-programmed with the testing code, and all you need to do is supply 9 volts power and some old DRAM chips. This kit cost me $21.95 from eBay, but is also available from PCBgeeks.com and other retro computer shops and sellers. Other versions are available, including pre-assembled units. The kit is made up of through-hole components, apart from 4 resistors, which are all surface mount devices and are fitted to the underside of the board. The instructions tell us to fit these resistors halfway through the build, but I think it would be far easier to fit them on a flat surface with no components on the other side. So after reading through the instructions, I've created my own order of fitting these components, which I feel will make it easier. And to begin with, we start with the SMD resistors. I'm using solder paste and hot air to fit these components, but using a normal soldering iron and attaching just one side at a time will also work just as well. As you can see, I've roughly smeared some solder paste on the pads, and to be honest I think this solder paste is past its prime. So now it's just a case of placing the resistors on the paste before applying some heat and melting the solder. Now for those who are interested, my hot air nozzle is set to about 300 degrees, the airflow is about halfway on the dial, and as you can see I'm using quite a wide nozzle, and this makes sure I apply hot air in a wide, even area, and I don't blow these components off the desk. Once soldered in place, I've allowed it to cool, cleaned down with some alcohol, and before I carry on, I just want to complete a resistance check to make sure I haven't shorted out the pads. With no other components in place and on a surface area, this is easily done, and once I'm happy, I can move on to the rest of the build. Next up is the Arduino header pins. I have the strip with the long pins that go through the board, and we can trim these down later on. Start by soldering just one pin on the end and check that all the header pins are level. Do this for the other side and then finish up by soldering the rest of the strips. Once done, grab some side cutters and then trim the header pins down so they're nice and low on the underside of the PCB. Go careful here, as you can see these pins do fly off with quite some gusto. Now I'm not going to fit the Arduino just yet, I'm going to do this last. So now we can move on to some capacitors. First up we're going to fit the 2 ceramic caps that fit behind the 2 voltage regulators. These go in any way round, so fit in, bend the legs and solder in place. Now it's time to fit the voltage regulators. The silkscreen gives us some clue as to which one goes where, but to look at, the 2 components look identical. One is a 79L05 and this fits in between the 8-pin IC and the ceramic capacitor. Double check that you've got the correct regulator and solder in place. The second regulator is the 78L12 and this fits in at the bottom left of the circuit board. Again, pay attention to the silkscreen for the correct orientation. Once soldered and trimmed, we can move on to the 2 diodes. These diodes fit with the white band facing towards the left of the circuit board. Again, look at the print on the circuit board to double check the correct orientation. Next up is the 8-pin IC. The notch at the top of the chip faces towards the left edge of the board. The silkscreen clearly shows the indication of the orientation. Make sure all the pins are through the board correctly before soldering just one pin. Apply some pressure with your finger on the top of the chip while heating up the newly soldered IC. This will make sure the chip is flat against the circuit board and it's in its correct position. The electrolytic capacitors are next, and we start off with the 22 microfarad cap, and that fits in the bottom left hand corner of the board. Pay close attention to the polarity. There is printed on the circuit board a very small plus sign, and the capacitor is clearly marked which side is negative. Fit the cap with the negative lead going through the white coloured segment of the silkscreen print. Repeat the process by fitting the remaining 3 10 microfarad capacitors, again paying close attention to their polarity. Fitting the LEDs is really easy. Make sure the longer lead faces towards the right of the board, fit the red LED next to the cross and the blue LED next to the tick. Next up is the power connector. I tacked one pin in place while holding the barrel on the board with my finger. With it only loosely tacked, I can adjust it for position on the board before soldering the other two connections. The buttons go in next. These can only go in one way round, and again just solder one pin in place and use your finger to make sure that the switch is seated on the board correctly. You can of course use tape if you're unable to use your finger, but I find it far easier to use your fingertip to gauge whether it's in position. Now we're almost there. The penultimate item is the ZIF sockets, and these fit in really well. Make sure the lever is facing towards the top of the board and solder it in place. These fitted in flat, so I was able to just solder straight away without having to adjust their position. The final item on the board is the Arduino. Before soldering, pay close attention to the position of the Arduino in relation to the pin headers. It's very easy to be just one pin out of position, as you can see here. Now if this happens, the circuit will not work and you're likely to damage the Arduino. So check and recheck before soldering the Arduino in place. And that's it, we're all built. Using some alcohol, clean up the bottom of the board, fit the rubber feet, and now we can begin to check our work. I started off by checking the continuity of the voltage rails. I also did a rudimentary check to make sure there was no dead shorts. Once I was happy, I added 9 volts to the circuit board. Now don't use a ZX Spectrum adapter here, what you need is a power supply with the centre pin which is positive. I checked for the +5, the -5 and the 12 volts on the 4116 ZIF socket, and I also checked for +5 volts on the 4164 socket, and it all looks good. So now it's time to check some DRAM. I've got 8 4116 chips I removed from my first Spectrum, and I know 1 or 2 of these are faulty, I just don't know which ones. So to use, open the ZIF socket, insert the chip, close the lever and press the test button. As you can see, the board will check the chip and give us a yes or a no. The blue LED is flashing while it tests the chip and then goes steady to confirm our chip is okay. And here's one which isn't okay. It didn't really take that long to confirm that this chip was broken. So, my conclusions on this kit. Well, the build is easy, the components are laid out quite well, but I can't figure out why there are 4 surface mount components. Sure, it's nice to have something that builds your SMD confidence, but to be honest with you, surface mount is easier than you think. But this would be a great introduction for those who've never tried surface mount soldering before. However, the only downside to this kit is the instructions. It would have been nice to have a full list of components, values and names in the instructions for easy ticking off whilst building. The order in which components are built also could be slightly different to make fitting as simple as possible. For example, starting off with the surface mount devices. But this can all be addressed in the future. Overall, this is a great project and I'm super happy that I've purchased it, and you will see this coming up in future videos. Like I said before, I bought this from eBay, the link is in the description below, but this along with some other projects is also available from PCBgeeks.com. Thanks for watching.